All right, everyone. Thanks so much for joining us today. This is Tyler. I'm covering for Alper, who had sort of an emergency come up, but may take over before the end of this call. I'm really excited to introduce today Vivian, who's a second-year PhD student at the Robotics Institute of Carnegie Mellon University. She does research with the Future Interfaces Group, advised by Dr. Chris Harrison. His background is in sensors, computer vision, and conservation. Recently, she's been working on haptics projects, which have been featured in venues such as Popular Science, TechCrunch, and more. On her free time, you can find her taking photos and playing way too much ultimate frisbee. She's also a former CodeDay volunteer from quite a few years ago, I think, right? Always great to hear from her. So with that, I will turn it over to Vivian. Thanks so much for joining us.
Yeah, hello, everybody. I used to do CodeDay back in high school, so that must have been 8 years ago. Wow. And so I did CodeDay in the Bay and as well in New York. And it's great to still be connected to the community. And so I'm Vivian. Like Tyler said, I am a second year PhD in robotics. I'm about to be a third year at Carnegie Mellon University. And my talk is going to be the Hows and Whys of a PhD, aka what is grad school for? So just a heads up, this is not a depth talk, but rather a breadth talk. And it's something that I think I would have found super useful in college because I wasn't really sure why any CS majors would get a PhD until I decided to do it. And so this is kind of an overview of like why you would do it and how you would get there. And I won't be delving into robotics or my own research in this talk. Those are actually talks that I've given in the past at CodeDay Labs. But if anyone wants to talk, feel free to email me. I'll have my email on the last slide. But first, a little bit about me. I did my undergrad at Columbia University. I studied computer science and mechanical engineering. And from there, I did a series of internships. I've worked at NASA's Jet Propulsion Laboratory, JPL. I did Disney research. I worked at a startup called Conservation X Labs. I did research at the San Diego Zoo's Institute of Conservation Research. And I also then did a stint as an Imagineer with Walt Disney Imagineering. I also forgot to put it on the slide, but I'm currently interning. I took this summer off of grad school to intern at Meta. So I'm at Meta Reality Labs right now. And I go to the Robotics Institute at Carnegie Mellon University as a PhD. My research, though, is actually involved with the Human-Computer Interaction Institute, which is a different school underneath computer science at Carnegie Mellon, and specifically with the Future Interfaces Group. You can see our website there. But my research is mostly human-computer interaction based, although I'm still working on computer perception, so computer vision and sensors. So the work that I personally do is the same. It just isn't on a robot. So first we'll start with why would you actually want to get a PhD? Oftentimes after we graduate from a bachelor's degree in computer science, we think that there's three routes. You know, you could go the university route, like becoming a professor, work in academia. You can go the company route. I guess this is outdated, it's now Meta, but the whole thing that everybody knows about, there's big tech companies, small tech companies, startups, you know, that's all industry. So I'm calling that category industry. And then you have government. And so government tech is different. A lot of it's going to be like civic tech stuff. And these are the kind of the three routes that I consider the three routes of post-grad life as a bachelor's. And so many people know that you already need a PhD to be a professor, like most of the time for any major, any discipline. So the academic route seems obvious to many. For that reason, I won't be going over PhDs in academia, since it's a pretty straightforward path. You get a PhD and then go be a professor. But there is this common misconception that for industry or for government, you should only get like a bachelor's or a master's, and you don't need a PhD. You know, you don't, like, if you get a PhD, it's overkill. That's actually something that people have actually told me, that getting a PhD would be overkill if I was trying to go into either of those routes. And, you know, that's not true. You can get any of those routes, and you can do any of these 3 degrees and go through any of these routes. And I'm going to focus on why you would maybe want a PhD when you're doing industry or government. So a common misconception of a PhD is that it traps you into a narrow area of expertise. It's only for people who really know what they want to work on. It's for people who want to work on products that aren't being pushed into the market. Like, they don't want to have to focus on the endpoint and the consumer, or that it's not useful, or that it doesn't have a much better income. I guess that's maybe not a common misconception. I think people know that, like, with higher degrees, there is like a requirement for higher income. for a higher salary. But the other ones are very common misconceptions that I've always heard is that people wanted to do a PhD but didn't know what they wanted to do, or wanted to do a PhD but didn't want to give up being a generalist, and so they were worried about doing a PhD. And those are misconceptions. Really, what a PhD is at the end of the day is just for learning how to do research. It's not about focusing on something specific. It's not about pigeonholing yourself into being an expert in only one thing. It's about how the general process of learning how to do research. In fact, the parallel that I often draw is that in high school or middle school, you are learning obviously a lot of content. You're learning the basics of like every single subject. But a big reason why school is important is because it teaches people how to learn in general. Once you figured out the methods for learning literature or math or history, those are kind of methods that you can apply to new knowledge. So when you're learning new things as an adult, you know how to learn. You know what works for you. Is it reading? Is it taking notes? Is it watching videos? You learn how to learn. And in PhD, you learn how to research, regardless of what your field is, regardless if you even do computer science, you learn how to research. So what is research? If you look up the definition for research, it is the systematic investigation into the study of materials and sources in order to establish facts and reach new conclusions. That's a very, very wordy explanation for what research is new stuff. That's what it is. It's looking into new stuff. It's establishing facts of the new stuff, reaching new conclusions, testing new hypotheses. It's kind of looking into new things. And so I'm going to kind of show a series of new things from the industry standpoint that I think are interesting new things that are considered research in industry. So for example, I don't know if anyone's seen this video, but this is Stuntronics, which came out of Disney Research. I'm also choosing kind of more robotics related research because that's what I do. But this is something that I found really cool in undergrad, which is they researched from that stick figure. Let me actually pause the video. Also, if the video is not playing, can someone speak up and let me know? But so they started with this stick. Like this is just a stick that they threw into the air and kind of put a bunch of sensors on it to measure how it accelerated, how it turned, how it rotated, understand the physical properties of throwing this like metal stick into the air.
The video looks good, by the way.
Oh, cool, great. From that, they extrapolated into a robot. Like they're like, what if we added like moving parts to this metal stick? What if we let it fold through motors? And something like that, all it's doing is folding in air and then extending again. So sorry, this keeps popping up. But that's like, they just added a couple motors. And they're like, okay, now we have something that folds in air and it uses its sensors to know when it should fold to preserve that angular momentum of the centripetal force. Let's add more parts to it, let's add more joints the way a human might have. Let's add legs and arms and a head. And you see now it's doing flips from here. And then this is kind of the final version before it was actually released into the park, is a stunt robot. And all of this started, I can't remember the exact reason. When I was there, they explained how this idea even came about. But I think it was literally like some researcher was kind of throwing a brick into the air of some sort for some reason, and he thought that the rotation that it maintained as it was like falling down was really interesting. And he was just like, I wonder if I can like release the brick in a certain way so that like it can go through a very narrow hole, timing the rotation of that. And he was like, well, what if I like use the rotation of objects in space to like make them do flips? And then was like, let's try flipping a metal stick, and how does the physics of that work? And like all of this came from just like a small thought that he wanted to entertain, and research allowed him to do that. Research allowed him to develop this very tiny thought into a full-fledged robot that does flips and stunts. And it's actually in the Los Angeles parks right now. Like you can see this robot doing flips. Obviously a very, very long process that I'm condensing into like a 1-minute talk. But that's an idea, that's a research idea that came out of industry. Another one that I really like, how do I go to the next slide? Okay, another one that I really like comes from AI for Good, which is a branch of Microsoft. I believe they call themselves Microsoft Earth is the research branch, but regardless, it's underneath Microsoft Research, and the team is called AI for Good. And the video doesn't have sound, but let me skip forward. So what they essentially did is they are developing kind of large, broad, open source, I don't know if they're open source, but programs for recognition. So that's like recognizing wildlife. Like this is identifying zebra by their stripe pattern and using computer vision to do that. They have AI for accessibility. So having computer vision that can recognize everyday objects in the world and that could transcribe it to someone who isn't able to do, who maybe like blind people who can't see, they can transcribe the world around them through computer vision. Rescuing, search and rescue, identifying people in rubble. Computers are really good at doing this when they have a lot of data. Here's identifying trees in the wild, you know, there's just so many different ways to use computer vision. And people are kind of on this new train of computers right now. So people are discovering, thinking of new ways that they can use this. And so Microsoft, this is like a whole score of tools, but they're just getting researchers to be like, what is computer vision good for? What is AI good for? And whatever new idea they can think of, they have enough data, you know, they have the resources to train a model, they go look into that. So that's another industry research coming out of Microsoft. The next one is the Mars helicopter, was a research project coming out of NASA's Jet Propulsion Laboratory. It was being worked on when I was there. But pretty simple idea. I mean, sorry. Let me skip ahead in this video. Pretty simple idea. We've sent a lot of rovers and landers to Mars, things that travel on wheels or things that don't move at all. A lot of landers land somewhere and they just never move. They take data there, they take pictures there. And someone's like, okay, we have moving ones on the ground and we have static ones, but like there are shots that we can't get when we're just so tied to the ground. How can we make something go into the air and maybe get us data or pictures that we wouldn't get otherwise? And someone's like, why don't we just build like a tiny drone helicopter? And then here it is, you know, it's an idea that it has been on Mars for a year, 2 years now. I can't remember how long. But it's just this little Mars helicopter. This is obviously a rendering of what the actual helicopter is, and it's a very dramatized rendering, but someone had this inkling of idea, something that flies into the air and sees Mars from a way that we haven't been able to in the past. And this is the conceptualized video of that idea. So why am I talking about all these new things coming from industry? Like, what's the point of this? Why does it matter in terms of a PhD? The common link between all these projects are that they're led by doctoral researchers. So if you want to be working on these projects, like you don't need to get a PhD. If you're interested in research, you don't need to get a PhD. You can research new things without having to get this higher level of education. But the leaders of all these projects that I've seen in industry are 90% of the time, probably higher percentage of that, doctoral researchers, people with PhDs who spent 5 years learning how to do good research and therefore become the ones who lead the teams that do research because they know they have the skill set needed to try to figure out how the evaluation would be most efficient and most cost effective and how to get to the endpoint that they're going for. And so all of these are really cool projects that scores and teams of people have worked on from all different backgrounds, not even just computer science majors, but the thing tying them all together is that they're led by doctoral researchers. So what does learning how to do research mean? Like, what skills do these doctoral researchers have that sets them apart and allows them to lead projects like this? A big thing is identifying important issues to solve. So for me personally, that's something that was my goal coming in, because I feel like I'm very good at tinkering and I can like build things when I have direction, but I have trouble giving myself that direction. I wish I was better at like identifying issues in the world that I would like solved and then tackling those. It's more just like, I want to be able to see what needs fixing or what needs building or what needs innovating. And that's like my biggest goal for my PhD. I'm still working on it. You know, I'm a second year and I've done a little bit of that, but I want to have those ideas come from inspired by things that I see in the real world. But what else does learning how to do research mean? It means like understanding which solutions are viable. There's a million different ways to build something, to solve something, but which one is, you know, cost effective, low cost, mass producible? What's actually a realistic solution that you can tackle and look into? Figure out what products are or aren't worth pursuing. I guess that's kind of the same thing, but like knowing what products aren't worth pursuing and why they aren't worth pursuing is also super important to learn. Learning how to start projects. I think one big thing when we do internships or we work on projects in college is that we are often given something that already has some sort of a skeletal framework, or we like jump in on a research project at school, maybe that's already been done. Or like when you're in classes, maybe you're starting a project from start to finish, but that project has a very clear, like, you need to make an algorithm that does this, like, or you need to make your own operating system or your own programming language. Like, we have our prompts and we kind of have a starting point because of that. And so learning how to start projects is really important, because that is that ties into like understanding whether this project that you're starting is, you're tackling in a viable way, and whether it's worth pursuing, and how to even get your feet off the ground for any ideas that you have. Being able to debug never before seen problems. I think this has been a huge thing my first year in grad school that I ran into, which is that whenever I've been doing internships or when I was doing classwork, if I needed help with something, I could find it on Stack Overflow. I could be like, why am I getting this error? And Stack Overflow will tell me exactly why and what I need to do. And we're all used to doing that, of course. And then when I started grad school, I would be working on a brand new like pipeline. I worked on like a computational photography pipeline, and I'd be like, why is this thing failing? And there was no answers on Stack Overflow. The first time I encountered that, I was like panicked, I've never experienced that before. But when you're doing new stuff, those are unanswered questions, and you're not going to be able to find all of the resources to help you answer every single thing you run into, because no one's tried it before. No one's tried to put this software package on this hardware component and it's not working. You're going to have to figure that out yourself. So there are methods to being able to debug never before seen problems. And that's something really valuable that I've already learned in my first 2 years, and I will continue to learn. And like a really big thing is selling the world on your ideas, which is that you've now identified an issue. You've found a path that you believe is viable and worth pursuing. You've started it. You're in the middle or end of it. You've encountered problems that you've debugged. How do you convince everyone else that this is something that's important, that they should listen to or learn from, or at least consider? And that's what papers do. That's what videos of research do. That sells people on your idea. And that's something you really have to learn when you're trying to get grant money or money to fund your ideas. You got to figure out how to excite people. And all of that is research. So a kind of analogy that I like to use, especially with the CodeDay crowd that's probably pretty familiar with hackathons, is that it's kind of like a hackathon. You come up with something and you make it. I mean, a PhD is obviously much longer than a 2-day hackathon, but you come up with the idea, you build out that idea, you build it into a minimum viable product, you pitch it to the judges, you sell it to your peers, just like a startup, which is a more drawn out form of that. I know a lot of people don't tend to think PhDs and immediately go like, oh, it's like a startup. But from what I've experienced with CS PhD, and from talking to a lot of CS PhDs that I know now, like, this is very much what it's like. It's fast paced, it's groundbreaking, it's new, and it's a very similar process, but drawn out over a series of projects over a graduate degree. So a PhD may be for you if you want to call your own shots. You want to be part of this team that is leading the project, that is choosing the path worth pursuing, that is coming up with the issues that need to be solved. You want to be working on the newest technology out there. Again, you can do this with a master's or a bachelor's. You don't have to do a PhD, but it's an easier chance to be getting onto those research teams if you do have a PhD. Like my team at Meta Reality Labs, I believe, is like 95% PhDs. Yes, something like that. Doing like VR, AR research. And then you're interested in impact. You can impact people in a manner of ways, in a manner of jobs, but definitely there's the chance to do that as well in a PhD. So now that I've kind of hopefully sold you a little bit on the idea of potentially even considering graduate school, the next question is, how do you get there? How do you get started on this path to a PhD, especially if it isn't something that you maybe considered before? And don't worry, I didn't decide that I wanted a PhD until my junior summer, and you apply for PhDs often if you want to go right out of undergrad your senior fall. So I was like I was not someone who went into college and was like, I'm going to graduate school. I was actually very much I will never go to graduate school until I interned at Disney Research, saw what the PhDs were doing, the doctoral researchers were doing, and was like, all right, that's what I want. So it's okay if you're unsure. It's okay if you've never thought it about before. You can still get there. I did. The first thing you should consider when you're thinking about whether or not you should and how you should get there is you should also consider the sacrifices that you're going to be taking. A CS PhD from every school that I've seen has been around 5+ years. Usually around 5, I think. A lot of schools have 6, some schools have 7, but 5 or 6 is generally how long it takes. And during that time, you won't be making a lot of money. The nice thing is that you don't have to pay for school. It will be paid for, but you won't be able to, likely you won't be able to save that much money because our stipends are not that much. I mean, I go to school in Pittsburgh, CMU's in Pittsburgh, and I'm able to have a good quality of life because Pittsburgh's a cheap city to live in, which has been very nice for me. But it's definitely difficult to save that much for like the time that I'm in a PhD. It's also 5+ years of your time in general. So if there's something that you need to be urgently doing in the next 5+ years, it might be difficult to slot that into your PhD. But from what I've seen, programs and professors are very flexible. It is just a lot of time though. It's a heavy workload. I do say that the hardest I've ever worked has been in grad school. And I do really believe that's true because unlike homework or like at a job, maybe you close your computer at 5, 6 p.m., you know, or when you're doing homework, like there's an end point to that. When you're doing research, because it's new, you can always work on it more, you know, you can always push it further. And that's something you have to balance of like working your hardest, but knowing that you're never going to make the most robust product market ready thing at the end of your paper, because that's not our goal. Our goal isn't, during our PhD at least, to like make a product that we then sell to the world. Our goal is to start the research on new ideas. And then because of all these things, it can be difficult on your mental and physical health. And hopefully if you do a PhD, you'll have resources that help you combat that. I've been having a really good time this past year, but I know my first year was hard because I wasn't used to the workload and it was a new environment. But since then I've made friends and I have a supportive lab and it's been honestly really great. So what do you need at a PhD? What are the ingredients to thinking about how to get there and like what you need to think about when you're applying? The first is a general field. Again, you are not tied to your field. Like I said, I applied to the Robotics Institute and I got into the Robotics Institute. I don't work on robots. I now am fully in the human-computer interaction side, and that's fine. I switched pretty early on and it's been completely okay, even though my entire background's in robotics. And I might, you know, go back in the next couple of years, but you don't have to be absolutely sure of what field you're going to, but it's nice to have an area to kind of meander towards as you're thinking about what internships and to do or what labs to aim for. And there's a lot of fields. It does get much more specific than just general computer science. So like this, for example, is just all the doctoral programs in the School of Computer Science at Carnegie Mellon University. And we have a ton. You know, we have computational biology is fully different from language and information technologies and societal computing. So have a field in mind, have a couple fields in mind that you're maybe aiming towards that have interesting problems that you think you'd want to tackle. It's not something to be strict about, but it does help inform your decisions of where to apply to and what labs to talk to. The second is a focus. So focus is, what I mean by that is like a technical area that you're interested in. So obviously there's fields, but like I said, I do sensors and computer vision, and you can apply that in any field. You know, I could go to computational biology and start working on computer vision and biology, or I can go to conservation, which is what I've done in the past, which is using computer vision and conservation. So my focus is the sensors and computer vision part, but that can be applied to any field. And throughout your PhD, you'll kind of hone in on like what your field is and what your focus is, and like they'll meet somewhere so that you're kind of doing both. But again, just like a field, the focus doesn't have to be like, I'm 100% set on doing this sort of technical problem. And also, it doesn't have to be something that you know already. I actually have never done computer vision before grad school, but I always thought it was cool. And even when I was entering grad school, people would be like, what do you want to focus on? And I'd be like, computer vision. Never even taken a class in it. I don't even know how it works, but computer vision. And since then, I've taken many classes and I've done projects in it, and I still really enjoy it. So I'm lucky in that the focus that I chose was something that I have stayed interested in, but it's also okay to pivot. Name question mark is all I mean by that is like maybe you want some sort of non-technical, like I'm talking about like robotics, computational biology, like human computer interaction. Those are technical fields. And then the focus is like technical focuses, since, you know, we're doing a technical PhD. So that's like computer vision, operating system, programming languages. Those are like technical focuses. But you can also have like the name of an idea that's unrelated to technical, that's something you want to focus in. I didn't have to explain, like, for example, for me, it's conservation. Conservation is not a technical field or a technical focus, but it is something I'm very interested in. And in my ideal world, I would apply my field and focus to conservation. And so that's what I mean by name. It's not the best name for it, but an idea or an area that you find interesting that doesn't necessarily have to be related to tech. You also don't need it, because some people are happy doing you know, computer vision and robotics, and where that is, whether that's self-driving cars or conservation, doesn't matter to them. But it's also nice sometimes when you're like, I like robotics, I like computer vision, and I like cars. So let me go towards cars is the name, and let me go towards car things that have my field and focus. So that's also something to consider if you're interested in ideas that aren't focused around technical aspects. And then finally, I believe this is my last topic, but what you need before a PhD. So what kind of experiences do you need to build? What kind of, I guess, what kind of a resume should you maybe have? I will say that for a PhD, I think it is so different from getting a job, because, you know, they really look at your applications holistically. So you might not have the best GPA, but maybe you had this really cool idea that you were able to build from start to finish, and like got some sort of acclaim for that. And like, that's great. A lot of labs will be like, that's fine. Like, who cares if your GPA is really bad? Like, you clearly have the knack for research. Or on the other hand, like, I have friends who never was able to do research in undergrad because, you know, maybe they were like doing work study and they didn't have time to like work for a lab unpaid, or any of that kind of stuff. But they did really well in classes and clearly showed that they enjoyed learning, and they also get into the PhD program. So I'll give kind of general categories for what you might need to get into a PhD, but there's no prescription for how to get in. The first one is experience. So that's kind of any sorts of experience you have with technical aspects. That could be internships, that could be research, that could be side projects are even good enough. As long as you show an interest, or like classes, sorry, of course, classes is one. You show some sort of interest in learning of some form, whether that's through building or through classes or through volunteering even. You show this kind of, you want to learn and you want to push yourself and you want to get the experience of working in these kind of areas. So experience is really important, because grad schools want to see what did you do and why did you do it. The second is relationships. For this, I don't mean that you need to go talk to the lab that you want to eventually do a PhD in and like schmooze up to the professor and be like, hey, like, let me in. That's not what I mean. But you want people in your life that you've worked with that can really vouch for you, whether that be your resourcefulness or your intelligence or your studiousness, how hard you work, because recommendation letters are a big part of the PhD application process. So for me personally, when I applied, I got a professor that I TA'd for. So I was the head TA and I had a great relationship with him. I had a professor that I did research for. So because I worked in his lab, he saw a bit of like how I worked outside of a school context. And then I had a boss from one of my internships. because he worked closely with me as well, and he could speak to like how I work and my work ethic and all that. But it doesn't matter who the people you choose are. You want to just make sure you have a strong relationship. So when they write that letter for you, they're not like, yeah, they're fine. Like they'll do fine. You want someone who'll be like, this person is, their heart is in the work. You know, she loves what she does, and she will push herself, and she works hard. Because grad schools really care about hearing those kind of testimonials from people who know you. The third is story, and I have an asterisk there because there's no right answer for what a good story will be. And I am not advocating for you to fabricate some sort of story about why you're interested in what you're interested in. But it is important to have motivation. You know, I know some people who applied to grad school just because everyone was doing it. They're like, okay, everyone's kind of applying to master's or PhD programs. I'll do it too. But really what grad schools want to understand is like, why are you invested in doing this? And why should they be invested in you? Because if you're someone who's passionate about either your field or your focus or the job prospects after a PhD, any of those things, if you're passionate about those things, then you will go and try hard to achieve them. And that's a type of person that a grad school wants to invest in. Versus if you're someone who's like, maybe I'll try it, like, and maybe I won't finish it. That's not someone that grad school want to necessarily invest in. So when I say story, I just mean really think about why you might want to be getting a PhD, and your why can be anything you want. But as long as you have a why and you're able to explain it well, that's something that really matters. And the fourth is good grades. So I said before that it doesn't really matter, but unfortunately, grad schools are a little bit of an older institution, so they still do look at your GPA. And if you have exceptional work or exceptional relationships or exceptional story, or like not even just exceptional, but if you're really strong in those categories, you can still get into grad school. You should still apply. But I don't want to tell you that grades don't play a factor at all, because they do. And from what I've heard talking to a lot of people, it seems to be like, if you can, try to keep your GPA above a 3.5. And that's like, that'll unlock a lot of schools. I do know there are schools that will say in their application that they won't even read your application if your GPA is below a certain level. I know that I couldn't apply to a school because they said, if your GPA is lower than 3.7, we will not look at your application. And I was like, okay, well, then I won't apply. And unfortunately, that does happen. So if you're still have a couple years left before you might be applying, just something to keep in the back of your head. But don't kill yourself over grades, you know, like don't stress out too much about it. You can be a strong applicant with those other areas. But it is something that you have to keep in mind of it. And finally, how do you start this path now that you've heard this talk? Maybe you're interested in actually pursuing a PhD. What can you do right now that'll help you get started with all of these things? And I kind of created this chart. Oh, it's really ugly. I really need to update the graphics on this. But this chart is something I created when I was talking to people about hackathons, which was a big part of my undergrad career. And unfortunately, is not so much as my grad career. I'm just very busy with grad school, but I was a big hackathon person. And people are always like, how do you get started with that? How do you start being a hackathon person and going to these things? And I think it's the same way. It's the same answer to the question of like, how do I start going towards a PhD and like starting on this path of research? So there's 3 categories. The first one is learning. I have an example of things that might be good to learn if you're going towards specifically robotics, but learning anything at all. Like if you have an interest in something, and go and like look it up. You don't have to wait to like take a class in it, you know, go on YouTube, tons of good resources on the internet in general. Embedded systems, electrical engineering, physics, especially embedded systems. I never even took a class in that. That was me just YouTubing or instructable tutorials everywhere. The second one is ideate. I think this one's really important, which is just think about ideas of what to build And you don't have to build them. It's just a really good mental exercise to start thinking about like, what are ideas that I think would be interesting? And it doesn't even have to be technical. I think something that's helped me a lot is like, I will ideate on like maybe art ideas, like artistic pursuits that I want to try, maybe like a painting or a cool drawing. Just kind of starting these mental gears going of like thinking of ideas, ideating in general. Sorry, I've used that word a lot, but that's a really good way to start thinking about research. And then once you've gotten to like what to build or what to make, what to draw, the next step is how to build it. And this is a continuation of that process because it's a really good mental exercise to think of a problem, think of a solution, and think about how to build that solution, even if you never put pen to paper or start coding or anything. And then, in my opinion, what the most important thing is why build it. That's something that's really hard to answer in a world kind of inundated with technology and new things popping up all the time, new apps popping up all the time. Why is what your idea and your way of building it important to you or to the world or to someone you know? Why? And this will really help in your research as well when you're trying to think of paths to pursue, when you're like get all the way to grad school, or even before that if you do research. These are the steps that you do in research. So when you start doing this to everyday things, like just simply what to draw, how to draw it, and why draw it, even if the answer is as simple as it's pretty, it's a good way to start turning those gears. And then finally is fiddle. So like I said, ideating on itself is its own category. But you can actually then go to the fiddling category, which is actually trying to build out some of those ideas. And that'll just really help with like honing your technical skills. And sometimes if you just like watch videos on things, you'll learn enough, but it's only when you put it into practice that you realize like, these are the things I need to learn more about. And these are the things that I understand now. And this is how it all connects. So like I said, I'm a hackathon person, so I'll always recommend hackathons. But most schools will also let you do research at school. So just try emailing professors and being like, hey, I saw that you have this project. I'm interested in it. And a lot of professors will do like unpaid research, but there are also a lot of professors that will do paid research for undergrads. And that's something really great to find at your school and figure out who's doing that and maybe getting in contact with them. And finally, side projects. Like you don't have to wait for events or for people to allow you to do your ideas. You can just start fiddling them on the side. Whether like you could just, there's a lot of really cheap ways to get into hardware stuff. And there's obviously a lot of very cheap ways to get into software stuff. So just trying an idea out, even if it fails, helps you get into that process of starting a project from the ground up. So that's kind of it. These are all robot things on my last slide, but that's it for the hows and whys of getting a PhD. Like I said, it's not something that I knew that I wanted until very late into my undergrad career. So you're definitely not too late to start thinking about this now. And if you have any questions, you can always feel free to email me. I'm more than happy also to talk about what I do in grad school, rather than just how I got here. And maybe that'll be exciting too, because you can learn about all the things you can do in grad school. But you can also find me on my website, which is there. And I'm on every website basically under my handle Shen. So that's like Twitter, LinkedIn. I don't know all the other websites, GitHub at Shen. So feel free to email me or reach out in any form and I'll be happy to talk. And yeah, I think that's it for my talk. If anyone has any questions.
Thank you so much for the wonderful talk, Vivian. I'm so sorry I was a little late. The public transportation in the place where I'm at is a little unreliable, so had to come a little late. But thank you so much for the wonderful talk. If anyone has any questions, as Vivian said, now would be the time. Please make sure to put it in the Q&A. Maybe to get it started, Vivian, what would you say is a moment where, I don't know if you had one, but while you were still in grad school, the moment where you were the happiest that you chose to go to grad school, if that makes any sense, where you felt the most returns on that investment of time, of effort, and money?
Yeah, so I would say that it happens quite often, honestly. But the biggest one is the people that I've met. I think people have such diverse interests in grad school, and they all have like different issues that they care about, and they all are really passionate about different focuses in different fields. And there are so many times where like I'll be getting lunch with a friend, and then their friend walks by, and we'll like talk, and they'll tell me what they're working on, and like you see their eyes light up, and they're like, I'm doing this really cool new thing with like nuclear fission. I literally had this conversation with someone like last month. Like I'm working on a way of like charting nuclear fission and visualizing it for researchers so that it's safer. And it's like, wow, I don't even understand the issue, let alone how you would tackle it. But this is something you clearly care a lot about. And I think that's really cool. And he didn't even know about this field either until like his third year of grad school, when he randomly talked to someone else who was really passionate about it. And he was like, let me look at that. And now he's really passionate about it. So really the happiest and most inspired I felt is when I've been talking to my peers about what they're doing. And I think there's just so much cool new stuff going on that like everywhere. At conferences, I'll meet people from other schools, and they're also doing really cool things that I love to talk about. And again, I don't even understand the basics of all of them, but it's just exciting to see people excited about what they're doing.
Awesome. Thank you so much. So someone is asking, usually if we are interested in PhD, when we are taking classes for our bachelor degree, when should we start applying for a PhD? So like basically, if you're in your undergrad years, when should you start planning and applying and kind of researching that PhD path process?
Yeah, so the actual PhD applications are almost all due your senior fall. I think a lot of them are due early November, or I think or like late October to like early December is when most schools require their applications in. I think most people start working on them the summer before that. So a lot of people start on their essays like early June. And when you're asking for recommendation letters, the etiquette is typically give at least a month. I asked at the beginning of June too. So I told them like, hey, I'm applying for grad schools in 5 months. Will you write me a letter? So ask as early as possible so that your recommenders can think about it. Also start writing your essay as early as possible so you can get people to look at it and edit it maybe. But you really only apply to a PhD your senior fall. And a lot of people don't get in the first round. Don't be discouraged. That is incredibly common. Many of my classmates in my PhD program right now applied a second time the year after, and then they got in that year. So like, it's okay if you don't get into any your first time. A lot of people also don't even apply during undergrad. They like take a year off and apply afterwards. It's the main reason people recommend senior fall is because if you're asking professors for recommendations, it's easier when you're still in school and they remember you versus like if you wait 2 years, they might not have as strong a letter because it's been 2 years. But yeah, so I would say senior fall, but no worries if you apply later than that.
Great, thank you so much. Does anyone else have any questions?
And if you don't want to ask, like I said, feel free to email me.
Yeah, for sure. Let's see. No, okay, there we go. 2 questions. So if we want someone to read over our essay, who should we ask for input? So maybe like friends or professors, or who would you recommend that they ask?
Yeah, so I would say it really depends on the relationship you had. I asked my friends, and I think that they did a great job of like helping with grammatical errors and maybe like phrasing that I had weird or poor that made it hard for them to understand. So they really helped with that. I think in terms of if you're describing like your research focus that you might want to have or your research field, if you could ask like a professor in that area, if you're close with a professor, it never hurts to ask. They might say no, and that's fine. I've had professors say no to me for writing recommendations and also for like looking at my essays. But they might say yes, and that would be great too. But your friends can also help with that if you have friends in the field or if you know of PhDs. Never hurts to ask, and you can always just be like, if you don't have time, that's okay. And then how to research PhD programs that are suitable for you. like I said, there's kind of three aspects to a PhD program, which is like the field, the focus, and the name. And I think using any one of those areas or a combination, if you have answers to all of them, can help you research your field. So I knew that I wanted to do like sensors. So I had a focus. And so I was like, okay, in what fields can I do sensors? And I was like, robotics. I guess that's a field that has sensors. And so does a lot of others. But like after looking at all the fields that like would let me work with sensors, I was like, robotics sounds the coolest. And so I applied to robotics stuff. But I know people who are like, I really want to do like programming languages. Like I think learning about programming languages, how they work is really interesting. So let me look up programs that let me focus on programming languages as like a field. And a lot of places have like programming language PhDs. And so as like, think about your answers to all three of those things. Or like, if you're interested in conservation, I know someone who really wants to do conservation and like read about different types of conservation projects and then found out that like you could do robotics conservation. He was like, that seems really meaningful. Let me kind of like think about doing robotics as a grad program. So if you can, answer one of those three questions and then start looking from there. Are there any exams or tests required to be admitted in a PhD program? So it depends on the PhD program. One thing about PhDs is that unlike like the Common App for undergrads, every PhD program has different application requirements. So for example, my school did require the GRE when I was applying, although I'm pretty sure that they got rid of that. So now you don't need that. So many schools do require specifically the GRE. Many schools don't, but that's pretty much the only test that would be really required, unless you're a non-native speaker, in which case you need the TOEFL, which I believe is an English language test. But yeah, mostly just the GRE, and that really just depends on the schools because a lot of schools also don't require the GRE.
Great, thank you so much for those answers. Yeah, if anyone else has any questions. So you might have touched on this a little bit in the talk, but for those who kind of did a more general degree in their undergrad years and still aren't sure what exactly they want to commit into, and kind of the three areas of research didn't really help. There's still many options that they can pick that they're even remotely interested in. Do you have any other suggestions for narrowing that down? Because a PhD, as you know, is like a huge commitment. So people might be kind of debating what they want to put all of that effort into.
Yes, definitely. And that's something that I found very difficult as well. And I think when you're just reading about different programs or reading about different fields, it's hard to really know if it's like you want to do it or if it just like maybe sounds cool, or maybe like none of them sound cool and you don't know how it feels to actually work in those fields. And that's why I have those categories of like ideating and fiddling. So kind of just reading about projects and thinking about projects is the ideating. And again, like I said, it might be a little difficult to tell just from that what you enjoy doing, which is why I really recommend fiddling. So if you can, try working on side projects on random things because you don't know what might stick. And maybe you have like a random game idea and you're like, I don't think I want to do games, but might as well try it. Or maybe you have like a design idea and then you use some design software and like that's what inspires you, but just like trying a lot of things. But you know, not everyone's into side projects. I know I personally found a really hard time to do side projects because I like always wanted to be hanging out and doing social things if I had free times and not working on a project. So how I did it is that I did school research. Like I said, basically every school will have research opportunities and you can research at schools even when you're not a student there. So I know a lot of people that just emailed professors from like random universities and was like, can I work with you? And they might say no, but again, a lot, like if you email enough people, someone's going to say yes. And so if you actually are able to do some research in like fields that maybe sound interesting and you can be like, can I work with you for like a couple months? And that'll help you figure out maybe that if you do want to do something or if you don't want to do something. And then hackathons is a great way too. If you don't have any ideas or aren't sure what you want to try building, you can go to a hackathon and just like join a random other team and be like, what's your ideas? Like, can I work on that with you? And I really think that like working on some field or focus, even if it's just for like a day or two, will help maybe like spark something where you're like, whoa, like I started looking into like how to do this one thing, and I actually think it's really interesting, like thinking about these kind of problems. Or you might be like, yeah, I spent 2 whole days on an algorithm like design, and that was really boring, and I never want to do that again. So really just like with these different venues of trying things out, just trying random fields and focuses until you kind of hone in on something you want to do. And a PhD is a big commitment, but I would say that in the first year, often at a lot of programs, you still get that time to explore. First years aren't really expected to get that much accomplished. You know, you're still taking classes and you're getting used to a grad program. So you do get some time to explore, maybe not fields as much, because you'll usually be like in a lab that has a field, but you're focused. Like, I know there was a robotics lab I joined, and when I was talking, or that I could have joined, and when I was talking about like what I would be doing, he was like, you can do hardware or software, or you can do the integration between both, or you can do the mechanical engineering or the electrical engineering, which I guess is hardware and software. But he was like, we need all of these on the robot. You don't have to decide which one you want to do when you join the lab. Just join the lab and you can try all of them and let me know which one you like the most. So you still get that time to explore in a PhD often in your first year. And if that's important to you, when you're also looking for a lab, you can explicitly discuss that. You can be like, hey, I like your lab. Will I be able to have some wiggle room to explore? And so finding a lab and like starting a PhD is all a negotiation. The main thing I negotiated with my advisors, I was like, hey, I really like your lab, but I want to be able to intern during my summers because I like working in industry. And he was like, yeah, that's fine. And that's how I ended up interning. So it's all a negotiation, and but you have the room to explore. If I could say a few words about my undergrad research, did I do it during the summer? How was that in general? What was my role there? So I did multiple research things completely by accident, actually. So the first thing I did was my sophomore summer, I did research at JPL, and that's through a Caltech program where you kind of email professors at Caltech and are just like, hey, can I work with you? And I sent out 30 emails and I got 2 responses, and one of them, gave me an offer. So I got, 28 rejections or 29 rejections, and that's normal. And so I did that during the summer, and it was research. And he was like, the person I emailed happened to be affiliated with JPL, which is owned partially by Caltech. So I ended up working at NASA, and that was pretty cool. So that was during the summer. My undergrad research was, I was like, I think I want to do robotics as after I graduate. I wasn't thinking about grad school, just like robotics jobs. So I looked up the robotics professors at my school, and I emailed all of them and was like, hey, do you have undergrad research positions? And all of them did. And I like talked to one of them, and I was like, what kind of researchers do you need? And he was like, I want a mechanical engineering researcher that helps design this aspect of like this robot. And I was like, okay, like, let me try that. And so I did that during the school year, my junior year. And it was like a couple hours a week and a lab meeting a week. So it was like around the same level as a class, I would say, a same time commitment as a class. And that actually helped me realize that I didn't want to do mechanical engineering. I thought that the design work was very tedious. It was a lot of like CADing something, 3D printing it. It didn't really work that well. CAD it a little bit differently, 3D print it. Didn't really work that well. I didn't really like that. And I was like, I'm going to move away from doing mechanical engineering, and I'm going to move, maybe I'll try robotics in a different context. And so that summer, I tried to like look for more robotics internships, but not mechanical engineering. And I applied to a couple. I ended up getting with Disney Research, and this was with Disney Research, it was also me just emailing people, and I emailed every single head researcher, so like 15, and one of them replied and gave me an interview, and that's how I got that job. And so after he replied, I told him that like, I think I want to try robotics, but I didn't like mechanical engineering robotics. Can I try something else? And he was like, yes, like we have like software. You could do like computer science on a robot. And I was like, okay, that sounds cool. And I did that my junior summer. And so like, sorry, the summer after my junior year, to be clear, is what I'm calling my junior summer. And that I really enjoyed that. And then also there was a bunch of PhDs, and I was like, wow, what you guys are doing is like the coolest of everyone here. Because there were bachelors and masters, but they kind of just like did what the PhDs needed to be done. And I was like, whoa, like you guys get to decide what gets done. How do I do that? And they're like, come back when you have a PhD. And I was like, oh, shoot. And so this was my junior summer, and then applications are your senior fall. So within like 3 months, I like threw together application materials and applied to a couple of schools. But yeah, so I did I forgot to say, but my first internship was electrical engineering. So I was actually like designing a circuit board and like wiring stuff together. And that was like fine, but I didn't have like particularly interest in it or like against it. And then I tried mechanical engineering, and like I didn't really enjoy that. And then I tried computer science, and I did enjoy that. So I also like kind of fiddled with different roles. I was lucky enough to like kind of think that I wanted to do robotics. So I like started with a field, and then I like so I like looked around in that field, and then I also looked around at like my focus, and I ended up being like computer science, specifically with sensors, but like coding to use sensors was something I really enjoyed, and that's how I landed where I am now.
Thank you so much, Vivian. Yeah, if anyone else has any last questions, we have about 1 minute left. Make sure to try to get it in time. If not, we will wrap up in a bit. So let's wait a tiny bit more. So maybe while we're waiting, okay, right here. So I know earlier you said it might take 5+ years for PhD, but have you seen anyone finish it before that?
Yes, I think one thing that I love about a PhD is, again, it's so flexible. It's like negotiating with your advisor for like what you want. It's like exploring your field, and like you don't have to choose until like the middle of your PhD. It's all flexible. And part of that flexibility is also like the timeline. So I actually have a friend who just like really did some great work in his first couple of years, and of course with help from like an advisor and his lab mates, but he was able to publish some pretty impactful papers. Like, and when I say impactful, I mean like people in the actual field read them and were like, this is awesome and helpful. And he's gotten like 3 of those in the first 3 years. And he actually, his advisor was like, hey, if you want, like, it seems like companies are really interested in the work you're doing. You could just graduate, and like, if you want to go to one of those companies and actually start working there and like really pushing your project from like midway to like endpoint. So he's deciding like maybe he will just graduate in 3 years. So everyone's, and like I know on the converse side, like I actually had a friend who did it in 8 years, but he wanted that. So he had an advisor for 4 years, and he didn't really love his research there. And he could have just graduated in another year, but he was like, it's worth it for me to switch advisors and switch fields and like do something I really love. And so he did that and was really happy and decided to stay for like another 4 years. And like after 8 or maybe 9 years, he was like, okay, I feel ready to graduate. So your timeline is kind of what you make of it, as long as you like are in constant communication with your advisor for like the length of time and what you want to do. It's super flexible. And then any advice for steps to do a PhD abroad? Unfortunately, I only really know PhD programs in the US and maybe Canada, but Canada's kind of the same as the US in terms of the PhD programs. So I apologize. I don't know much about PhD programs anywhere else but here. And I don't want to lead you wrong, so I won't try to answer that one.
No worries at all. Thank you. I think that will be all the time we have. Thank you for going over the scheduled time, Vivian. I really appreciate it. Yeah, so I hope everyone has a great day. Thank you so much again, Vivian. It was a pleasure to have you
Yeah.
talk for us again today. And yeah, I hope everyone has a wonderful day.
Yeah, thanks so much for having me.
Of course.
Bye.
Bye.